Hey, how y'all doing? Good afternoon, everybody. Y'all good?
Yeah.
Excellent. How y'all feeling today? How you feeling today? Good? All right, excellent. All right, so today we're going to continue our discussion from yesterday where we was talking about distributions and kind of shapes and different type of plots. Real quickly, what type of plots, what type of graphs are you seeing at your desk? What type of graphs we discussed already? Talk to me. Say one. Box plot. What else? Dot plot. What else? Histogram. Excellent. Those are the big three. Okay, that's what we've been talking about. All right? So, before we even get started today, I want to see how much you remember as we start off this new week. Can y'all find a little slip in the middle of y'all desk? Do y'all see them? Yep. Excellent. Anybody got them? Excellent, 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 excellent. All right, y'all can share them as well. What I want y'all to do, in less than, we're going to time it off for 2 minutes. Sebete, put on the clock for 2 minutes, okay? All right? We're going to do 2 minutes. I want you to write down at least one thing that you recognize about that ticket at that table, okay? And also try to make sure that your group come up with different things at the table. I don't want to see one thing all around, all right? Y'all got it? Understood? Understood? So make sure you have notebooks out. Let me see those notebooks. Excellent, excellent job, excellent job. Let me see those pencils. Well done, well done. And let me see you get started. Do y'all see what y'all? First of all, real quickly, what's at your table? You got a dot plot or box plot back there? What y'all got? Block. What you say? Box plot. What y'all got over there? I see a histogram over here. I see a dot plot over there. Good. So we got a whole bunch of different things going on. I'm gonna start y'all off in 3, 2, 1. Go. Write at least one thing about that at your table. And you'll see it up here as well if you need to read the instructions. The pictures that you have all show distributions of different data sets. Using your own words, try to describe the shape of each distribution. So describe it a little bit. Tell me something about it. All right? Oh, by the way, there could be more than one word to best describe your distribution, okay? Come up with anything you want. All right. Excellent job, Perry. You good? Appreciate it. How much time we got left in bed? Minus a minute from that. We got about 30 seconds? Mm-hmm. We got about 30, 45 seconds.
143.
All right. I see some good stuff. Hey, that's not time yet? Somebody? Yes, it is. Remember, we got to subtract a minute, dog. All right, so we're just about done. So we're going to stop right now. Everybody, stop where you at right now. Let's see what you got. Let's start over here. Okay, real fast. Read yours out loud.
It's about that, right?
Yep, tell me what's that.
I said on both ends, they both got the number 7.
Actually, matter of fact, let's take a look at all the distributions so we can see what we're talking about. All right. So let's start off with what letter do you have? Look at it. F, okay? So you got this one right here. Okay. Anybody else share F? Okay, got F. All right, so what you talking about for F?
I said we both got number 7.
He said, yeah, both got number 7 in it. Okay. What do you mean by that? Explain.
Like that side at the end got 7.
So it's like a 7? Okay, you did a nice little notice. Okay, they both got 7 in it. What that kind of mean? Because they two different numbers. What numbers are they? Say it. What numbers are they? Where they at? 7 and... Exactly. So we can even make that a little better. He said they both got 7. Let's be specific. What's the space between them? Say it again. 10. All right, you could just say that. All right. Now, we also call that a different number. When we take the lowest number and the highest number from each other, we call it the what? Anybody remember that? Minimum and maximum. And when we subtract it, we call that the range. Well done. Excellent. Good memory.
Somebody lost their ticket.
That's okay. Range, okay? Excellent. So 10 is equal to your range. Well done. Excellent job. Well done. Perfect. All right, let's go. I'll be going to y'all next. Yeah.
Everything on our dot.
All right, let's go. We're going to do all three of y'all. What y'all got? Let's start.
I said everything on our dot slide. We not our dot.
Wait, what letter y'all got?
We got H.
Y'all got H? Okay, so for this one, the range was 10. Oh, my fault. Let's go back to F real fast. I want to hear one more thing about this one before we get to yours.
Okay.
One more thing. Anything kind of noticeable about it? The median, what's that? Good job, it's 12. Notice that it's 5 from 7 is also 5 from 17. Which means, how do it look though, as far as distribution goes? Like, is it unbalanced, uneven, or real balanced? It's really balanced. You see, who said that? What'd you say? Yes, it is symmetrical, okay? And that goes back to what you was getting at. Perfect 10, if they 5 apart, it got a lot of symmetry going on. We're gonna see a lot of that today. Well done. Y'all look already ahead. Y'all haven't even done this lesson yet. Well done. All right, so with that being said, let's go on. What letter you was talking about?
I was talking about H.
H, I had H? All right, let's go to H on folks. Yes. All right, let's go.
Everything on our box plot is even.
Oh, they got a box plot? Is that a box plot, y'all?
No.
What's that, everybody?
It's an Instagram.
It's a histogram. It's okay. It's still, they all still represent the same data. Yo, go back. You're good, though. You was talking that good stuff. What you say? It's all what? Even. You good. Kayla, what you gotta say? Talk to me.
I see a histogram with all the same things.
Look. Oh, she said she see a histogram with all the same data. That's how you put that in your own words. Well, simple. How about you?
I said, the histogram is equivalent.
Yes, it's equivalent and it's symmetrical. Well done. Right? You fold it in half. It's gonna be the same. Y'all doing some good words. Okay. Well done. Excellent. All right, we got this kind of uniformity going on. We'll discuss that a little bit later, okay? All right. All right, let's move on. What we got right there? Nay, talk to me. Which letter you have? B? Ooh. What you guys say? Talk to me. What you think about this one? Say you think about it. The sentence that's you're supposed to do for you, didn't I? You said, oh, I like that one. Say that one. It's built like a what? It's built like a triangle. Okay. I think I kind of get what you're kind of saying. Hey, right here, what you guys say? It's negative? What does that mean? Oh, they all are negative. Well done. I thought you didn't peep that myself. Well done. They all are negative. Okay. Got it? No. All right, so, excellent job. I heard some real good stuff. Anybody else? Anybody else got something to say about this?
No.
What city we in?
It's a bell jar.
Oh, it's a bell jar, right? What city we in?
It's
Philadelphia. So,
What?
in Philadelphia, if you go downtown, you notice y'all celebrate like this little when that shit like that, right? What's that called? The what? Y'all ain't never see that thing downtown like that? A little crack in it?
Yeah.
What's it called? Yeah, it's a Liberty Bell. It's a famous Liberty Bell, right? It's very famous.
Why you draw your belt like that?
I mean, that's how bells look.
That's valuable though.
So we call this a bell curve or bell shape. When we talk about distribution, we'll talk about this more and more today. Well done. So far, you did really good. Let me have one more person share. Sam, what you got?
Let me go.
I might go ahead.
So we got C.
See, what?
And I
Ooh,
said-
see, yes.
That's what.
See, okay. Talk to me, Ryan.
And it's going like this dot plots, right?
Is that a dot plot?
Am I stupid?
No, you're not. You're actually very smart. Is that a dot plot?
Huh?
Yeah.
You say yeah?
Yeah.
Excellent.
And it does.
Just because I asked y'all the question, I'm a math teacher. If you're confident what you got, you know what you got, okay? Yes, it is a dot plot. Keep going.
And it's going highest to lowest.
And it's going highest to lowest. Oh, am I on it? I'm sorry, yeah.
C.
It's high.
The C.
Then it go low.
And then what happens after that?
What?
Say it again, Kelly. Finish it up. And they go high again. So y'all both straight. The data started off, it peaked at the beginning, it went low, and then it rolls up again, okay? Kind of got these two shapes of that. What, is that shaped like a letter or something that you kind of label it?
No.
Not shaped like a letter? Like a what? It is like a U. Yes, a lot of mathematicians will call this U shape, okay? I'm done. All right, so we'll discuss all these things as we go on.
I got D.
You got D? Oh, let's see what you got on folks. Oh yeah, it's one of y'all. It's one I want everybody. Huh?
On the plot?
Yeah, this. Talk to me. What about this one? What about this one? Talk.
What's she?
Kelly. What about this one?
I got D.
Why?
You talking about why I got D?
I mean, why? What did you choose? Excuse me.
Oh. All the numbers on the plot is negative, and they like
All negative.
highest to lowest.
Highest to lowest, big, and they get, this get more positive as you're going that way. And what else you notice about the dots? They all what?
Even.
They all even. Which one? Whose was it similar with? Let's see what you remember. What group? What group had histograms like this?
I think it was no.
Give them in the back. Excellent job. The histogram in this dot plot actually some very same data. Maybe same data or something like that. Excellent job. All right. Before we move on, I really want to get to this one. Anybody notice something about this graph? What's this?
I forgot what I do.
What it's called?
Y'all forgot I don't call it. It's probably something you told us.
I don't need no jacket.
Yeah, I mentioned that jump.
I
Skewed. Say skewed. Skewed. Okay, this data is skewed, okay? Alright? That means as the data moves to the left side, what happens? What happens? It does what? It gets smaller, okay? So we says this is a left skewed data set, okay? Or this data set is skewed left. Right? You see what I'm saying? You see what's happening? It's almost like what shape? What shape is it close to but not in? A little bit.
Dinosaur.
See it? It's almost like a bell shape. You see, if the data ended like right here, it'll be like a bell shape. That means the data that you predict on this side will be equal to this side. But it's not. As you go up, what you notice is it's still some more data. There's a whole bunch of residual data, okay? A lot of little kind of outliers, data that's away from the set. The data is skewed, okay? Make sense? Even though the majority happens here, you still got data to the left. Now, this is also a type of data set that's not what? Remember that word she said earlier about her data when you fold it in half? What's that S word we're looking for? Symmetrical. Is this it? No. Skewed data is never symmetrical. You understand? Unless we're dealing with a certain type of data set. And we can also take a peek at that later. Okay, everybody, are we comfortable with this? This look good, yo? Well done. You did an excellent job with this. All right. So before we move on, let's get some stampers real quick. Can we have some stampers? Let's go. Kelly, Maya, Sim, let's go. Let's get that table. Y'all got me later, okay? There you go. Oh, your mom picked it up? Let's get some work done first, okay? You doing good? We got a grip. Yo, so what's about to happen is Sim's gonna be stamping your name, date, title, etc. Alright? Next.
What I said?
He's about to tell you.
Oh, my personal life.
Next. Kelly is gonna be stamping objectives as you're writing them, okay? You're gonna be writing the second one right there. I'm gonna box it for you. Alright?
Oh, where your objective?
He just put it in.
Bro, you really
Alright.
said that.
Yeah, the objective is the one I put the box around only, okay? And then finally, Maya is gonna be stamping your do-nows, okay? So she's looking for the letter that you chose and one reason why that data set was different from others, or why that the description you wrote for that data set that you have. All right, point to it if they don't see it. All right. So right now you can chat amongst yourselves and do whatever. Well, I'll give y'all 2 minutes to write on the data set to get prepared for today's lesson. By the way, y'all did an excellent job. And y'all work yesterday. We gotta continue that. Hey, here, I'll just go online too and look at your work on Excellent job. I see some good stuff.
Wash my hands, bro.
Appreciate you, son. Yo, step yourself actually. Alright, step yourself an extra time. Son for stabbing. Excellent job, my boy. I got you. That's well done.
Yo, where my other stamp at?
Did you step there?
What?
Hey, where's this other stamp at? You heard him, but don't disrespect the stamp. You're talking to me. Don't disrespect the stamp. Make sure you stamp where they actually stamp at. Don't be the.
Yo, Kelly.
No, yeah. Kelly chilling. Let Kelly do what she's gonna do. All right.
Kelly, you ain't give me no stink.
All right, while they up, moving around. Yeah, let's discuss
Hold up, don't. I got right here.
today's agenda, okay? First was which doesn't belong. Actually, we switched what doesn't belong. I just want y'all to identify and describe some cool stuff for you. We'll do which one doesn't belong. Maybe at the end as a finisher. It's also on your slide set, so if you need to see them, you can access your slides and play and do that. Which one doesn't belong? I'll give you some extra credit for it, right? I know I was like meeting yesterday. Talk to me about here. Yes, let me go over the agenda, okay? Next. My head big? Oh, Kelly, your head is big. All right. Next, we got practice examples with group on poster. We're gonna put something on a poster today, so we get some paper, some work on our boards, okay? And we'll do some fun stuff. Next, we got notes on shapes and distributions. I'm gonna pass those out. Y'all got them. We'll go over it really quickly, and then we'll move on into the decimals assignment, which you didn't have, and work on a physical copy assignment. Okay. The practice examples will also be on the poster board. Anybody got questions about that? And we'll go over some quick review and reflection at the very end of today's class. Excellent. All my stampers finished stop. Finish stamping. Anybody stamp this extra time? Well done. So let me have. Neil and Taylor is passing out some stuff for me. Same. I'm also going to pass out some cool stuff. Now, before we even begin to move on, I want to ask y'all some stuff. All right? What are some shapes of those data sets that you had earlier that you remember right now? Say some shapes. What y'all was saying. Describe some of those descriptions. I want y'all to say the words out loud. Go ahead. You said what? You said what? A bell shape. Well done. What's that S word I said earlier? Okay. What's the S word you said? When the data gets skinny towards the end. Kayan? Okay. It gets what? Skew. Well done. Alright.
Oh, never mind.
Yo, what's the word you use
I didn't get
when
one.
the data don't change? The only looks the same. Huh? Say which one? You say equivalent, equal. I mean, symmetrical, they're definitely symmetrical. Well done. And we also can call it uniform. We'll see this on our uniform. Like you wear it what? So we're gonna do our notes a little bit different. You mind?
Their phone.
What you do? I'm already done. Anybody missing one?
I didn't get that.
Anybody got some notes?
I need it.
I need one.
No, I don't got one of those.
You're on the same side for me, I can share it. Get up and share it. Y'all can share it. These are some quick notes, okay? Some notes that we made. All right. So real quickly, let's get out our notebooks. I'm gonna open up that first page. How do y'all do now? I want to write some notes. I wasn't gonna draw them, but let's draw them. I want y'all to kind of describe with me. All right? I won't bring any of you up because obviously we got the camera going. But y'all tell me how they may look, may or may not look. Let me go. All right. Let's go. All right, let's go to work. Huh? Oh, on your notebook, just your notes. All right. All right, we got different types of data sets, huh?
Freshman page?
Yeah. Sure. All right, let's go with our first one that we saw a lot. We're gonna do. Okay, yep, this is your notebook. All right. Draw L, a line, another L. All right. And remember, our data is gonna be like a little. I want y'all to draw your own personal drawing. Y'all gonna earn stats for these too, okay? All right. The first one, we're gonna make this a histogram. Make it to your liking. This is my personal one. All right. But thank you for saying that's too much. If I do too much dots for you, and you can think you can describe it or draw it in a better way with less dots, please do. All right. I was the same way, Kayla, when I was in college. I made sure that I did stuff a way that I could understand the best and the quickest way I could understand. Okay. And we got dot plot, Instagram. What else should we have? One more.
Black part.
Okay. We can even make this a little closer. Alright. Got those. Everybody. Everybody. Now, we usually would have y'all come up and draw, but let's go right now. First of all, what type of distribution is this? Let's look at our notes. Look at your notes. What type of distribution pattern this look like? Huh? IoT, not in order to. I said, what type of distribution pattern is it? So yes. So yes. So where is the central tendency? Where does the most stuff happen for this one? For this type of graph? Where's the most data happen? Where's the central tendency? In the middle, right? In the middle. See all the dots in the middle? Towards the middle? That's the central tendency, okay? Right in the middle. Let's look at this right here. And let's look at that first column. What does it say?
What paper is it? I don't got it.
Oh, right here.
So tell me what type of pattern is that? Come on, talk to me. Y'all know what this is. Y'all just said it earlier. What does it shape like if you was to draw a line around the data? It's shaped like a what? Bell, a triangle, bell shape. I like bell shape better, but it is shaped like a triangle. You're right, okay? Now, the reason why it's more bell than triangle is because you notice as you get towards this top, sometimes they'll round off a little bit, okay? So we take a line and we like to draw it like this, and we say it has a bell-shaped data curve, okay? So we say bell shape. And we also call this what? Symmetrical. Okay? This is bell shaped and it's symmetrical. I think it's two M's in symmetrical, correct? Bell shaped symmetrical. Got it? So if I was giving you a card and I gave you one with one of those pictures on it, and I actually describe that picture, you're gonna say this histogram is what? And it is
Sorry for the interruption.
well done.
Brandon Williams, report to the library.
You see a lot of data distributions bell shaped. Actually, a lot in this world is bell shaped. We'll go over tomorrow some real life representations of when you drop marbles and things of that nature, and how most of the data is gonna land in the middle and it's gonna curve out like a bell. This is some cool stuff. Next. All right. Make sure everybody got it first. Everybody got it? Next we got something a little similar, but it's kind of the opposite. Look at this histogram. All right.
I know.
What y'all know about that one?
It's a
Oh, yeah. All right, excellent. This one kind of shaped like, instead of a bell, nah, do it the way you want to. You don't have to do this with dots. I just want to make sure it's very identifiable. Good job, yo. Y'all writing pretty fast. Y'all getting ahead of me. Good job. Y'all writing them pretty fast. Okay. Yeah, I see some of y'all came up with your own pictures. Excellent job. All right. All right. So, the fact that most of y'all already got that one written down and drew up, we can explain it real fast. If you draw a line straight through, it's shaped like a what?
U.
Good job. You drew a line straight through, it's shaped like a what?
You.
Yep. And here, you probably wondering why it looks like this. It's bigger. But why is it big in the middle here and small in the middle here?
That's symmetrical.
Well, we noticed that the data kind of wings out towards the edges, and you kind of see it wings out towards the edges. Whereas here, the data is what at the edges? It's really high. It's a lot of stuff going on at those edges, right? And therefore, it pulls the Q1 and the Q3 towards the edges. Remember how Q, you gotta know how Q, good job. All right? It pulls those towards the edges of the data sets. See, the minimum number here is like, say if it was 15. But it's all this data here, so it's like 13, all that. And that's gonna pull all that data towards that maximum number on this side. And the same with the minimum numbers, okay? Whereas with a bell shape, the Q1 would be somewhere here, but the minimum was all the way over here. You see? Q1 would be here, but the minimum was all the way over there. That makes sense. All right. So when we talk about bell-shaped data cycles for the box plots, we look for a smaller box, longer whiskers. When we're looking for U-shapes, we'll see a bigger box, small whiskers. Make sense? Well done. Excellent. I see already y'all moving on into the next description. Okay. Excellent job. Our next description we're gonna do is, y'all tell me which one should we do? Skewed? Bet. Somebody said skewed. All right. We're going to do both skewed. And this one, oh, by the way, let's describe this U-shape real fast. The U-shape, is it bell-shaped or is what? U-shape. I saw y'all wrote it. He just reminded me. And is it symmetrical, yes or no? What does symmetrical mean? Even on and 4.5. Is that even 4.5? It's not? Or yes? It is, right? If you fold that on the half, it's even. It's just the opposite direction. It's the opposite way. Well done, Kyan. So it's still symmetrical. It's just U-shaped, okay? Now we're going to talk about some alternative stuff. So now we're going to go into, like he said, we call it a skew. Actually, I'm even edit that more. I heard some with the freaks. All right. I like to hear that. We creating skewed data sets, all right? By the way, for the box plots, you don't really need that line, but it's easy to separate. All right, real quick, some notice and wonders. What do you notice about this skewed data sets? Say again? It's going to the left, or most of the data is towards the left. Well done. Which way is it skewed though?
Left.
No, well, so skewed means getting smaller. Which way do it? It's okay. So it's skewed right, so that's okay. You gotta call me. You know that, right? They gotta call me. They gotta call the room. Tell them to go to the office, call the room. I can't just. All right, so everybody, we call this a what? Right. Skewed. We call that right skew. Skew to the right side of the graph. That means the data gets really, really small as you go towards the right. So right now in your notebooks, I want y'all to all draw me a left skew data set. Oh, y'all already jumped into it. Well done. Excellent job.
Yo,
Oops.
shush, yo.
Huh?
The computer tripping.
All right, Kelly, good job. Well done. Perfect. Yeah, you clap it up for yourself. Y'all can clap it up for yourself. Oh, folks. Give me a left skew. Well done. Excellent job. All right, keep it up. So, oops, you're not ready to that page, and that's okay. All right, because we're gonna jump back into that left skew data set. Actually, let's jump in this one. This is a perfect example. Did y'all data sets look like this?
Yes.
It did. A lot of y'all data sets look like this. All right, this is a perfect example of a left skew data set. As you see, the data gets real thin towards the left side of the graph. If you had something like this, you got it right. All right. You did well. If you had something similar, you still got it right. All right. Now, I want to also I want y'all to put a note under them already because I know a lot of y'all did already. Yo, we start off with the words. We say left skew, or it might be what? Not left skew, but right skew. So this one is left skew. And we're gonna ask ourselves, is this symmetrical?
No.
No. We talked about it earlier. All right. Skewed graphs are inherently non-symmetrical. Make sense? So we're gonna say asymmetrical, non-symmetrical, or not symmetrical. Right now we're gonna keep it simple. This is not symmetrical. I want y'all to overlay a not. And I want y'all to put emphasis on the word not, okay? All right. Not symmetrical. Now we do have two more. That's not on your any of your notes. I didn't give you yet. Yeah, it's in there already. Yeah, right there. Excellent job. Good job. All right. Now we got two more that we're gonna discuss real fast. And I don't have to draw this one because you know this one. I'm just gonna give you the names. All right, for this graph here. We have a dot plot. It looks exactly the same. Y'all saw it earlier. All right, and then we had, what's the last one? A box plot, okay? Now, a lot of people don't understand the uniformity of a box plot. But when a box plot is uniform, the difference between the Q1, Q3, Q2, and minimum maximus are almost exactly equal. That's the same as that, the same as that. And so you end up with this uniform structure. Anybody, guess what we call these? These are uniform. This is uniform. And symmetrical. I got it. I saw already saying you worked out too. Well done. The two names of this is uniform and symmetrical. Well done. Excellent job. That is correct. All right. With that being said, let's go over this last one, which is personally my favorite. All right. You know actually why it's my favorite. This is we're gonna write it right there. It's a type of distribution you're gonna see, and I will quiz you on it. It's another distribution. We're only gonna do a dot plot version of it and a histogram version of it, okay? And we call it a bimodal distribution, okay? Now you can see bimodal distributions in different ways, right? Bimodal distributions is, well, what do bi mean? Somebody tell me what bi means. Bi, B-I. You said, yes, exactly, it means two, right? Like if you're riding a what? A bicycle, right? A bike, right? Bicycle. Two wheels. Cycle means wheels, bi means two. right? If you speak 2 languages, you are bilingual. There's another word with bi. Exactly, right? That's attracting into sexuality and genders, right? She said it already. Alright? Bipolar, 2 opposite ends, 2, right? You hear it all the time. There you go. So, modal also means humps. And I could be mistaken, but I'm pretty sure modal means humps, okay? This is an ugly dot plot. Alright, should be good. Now, modal means hump, bi means 2. So when I tell you a graph is bimodal, that means it has 2 what? Hump. Exactly. In this case, it has 2 humps. Put that. Oh. That was funny. And yeah, hold on. All right, excellent. So now we got all these descriptions. I know it was a long lecture. I'm getting tired. I know. We're just looking at something new. Y'all caught on pretty fast. That's 30 minutes. But now you got some work in front of you all. And so you done? No, you're not done. All right.
What you mean you're not done?
Not done the one you gave us.
All right.
Right, for sure.
And we're gonna move on to that right now. All right, can everybody see the boards? Excellent. All right. We're gonna work this as a group, and you got a whole page that you're gonna do on your own. Let's start by writing our names and our dates on top of our papers. Let's go. Name, dates on top of the paper. Oh, y'all already did it. Name, dates. Well done. Date. All right. So all these new descriptions, all this stuff you learned, let's read this question out loud. It says, using the shape of distribution to compare the mean and medians and modes. Oh, by the way, we're going to reincorporate some mean, median, and mode stuff. So it says for each dot plot below, determine the shape of distribution. Is it symmetric? Is it skewed? Is it uniform? Is it bell-shaped? Or is it bimodal, okay? I can have multiple meanings or understandings, all right? Okay, some can be multiple, some don't have to be multiple. And you'll do that on your own. Then if the distribution is symmetric, skewed, or uniform, use this shape to compare the mean and mode. Guess. I want y'all to guess where the mean might be, or where the median might be. You can actually solve the findings, all right? I want y'all to write a sentence or two. Tell me how the median and the mode will be affected, the median and the mean will be affected by some of these skewed data sets like this one up here. How would the bimodal situation or this type of situation affect the median and mode? I want y'all to think about that. We'll discuss that a little bit later. All right, what's up? Yeah, hold on, okay? With that being said, everybody understand what we gotta do? Yep. All right, let's start with the first one. I want y'all to kind of write for this. I'm gonna give y'all about 2 minutes. We'll do 2 minutes, discuss for a minute, 2 minutes, discuss for a minute, 2 minutes, discuss for a minute, 2 minutes, discuss for a minute. Sound good? Everybody right now, describe. Actually, let's do it all together. I want you to write a word to describe A, B, C, and D. Everybody, ready, set, go. Read those instructions right. There we go.